Imagine this. Your lungs and brain chatting away like good old friends. Sounds like science fiction, right? Well, not anymore. We're here to unveil a groundbreaking discovery that has the potential to rewrite the way we perceive sickness response. Traditionally, we've always thought that the immune system is the sole hero, fighting off infections and causing symptoms to alert us of an ongoing battle. But what if we told you that's not the whole story? Researchers from the University of Calgary have found that during infections, our lungs and brain communicate directly with each other. That's right! They've been having their own little tete-a-tete, and we've only just found out. This discovery challenges our traditional views, shedding a new light on the way we understand sickness response. But how does this work? Well, it turns out that it's not just the immune responses that trigger symptoms of illness. Our study reveals that neurological pathways, those intricate networks that connect our brain to the rest of our body, play a significant role in this process. So, when you feel under the weather, it's not just your immune system sending out distress signals, it's also your brain, acting upon information received directly from your lungs. So, what does this mean for us? It suggests that when it comes to treating respiratory infections and chronic lung conditions, we may need to rethink our approach. It's not just about waving the white flag to the pathogen. We might have to include our nervous system in the conversation too. And as we delve deeper into this intriguing dialogue between our lungs and brain, we're bound to uncover more fascinating insights that could potentially revolutionize the medical world. So, stay tuned as we continue this journey of discovery. After all, who knows what other secrets our bodies are keeping from us? For now, we leave you with this thought. Next time you feel sick, remember, it's not just an infection, it's a conversation. Now, you might be wondering, what does this all mean? Well, let's dive into the implications of this fascinating discovery. So, we've established that the lungs and brain have a direct line of communication during infections. This challenges previous beliefs that the immune system alone was the master puppeteer behind sickness symptoms. But what does this mean for us, especially in the medical field? Well, firstly, this discovery could potentially revolutionize how we approach treatments for various lung infections and chronic conditions. Traditionally, we've focused on targeting the pathogen, the invader causing the illness. But with this new understanding of the lung-brain dialogue, it's not just about the pathogen anymore. We also need to consider the role of the nervous system, the brain's own network of pathways, in triggering symptoms of illness. Imagine treating sickness like a two-headed beast. On one side, we have the pathogen. On the other, the neurological pathways in the lungs that trigger sickness symptoms. By targeting both heads, we could potentially develop more effective treatments, perhaps even reducing the severity and duration of sickness. But the implications don't stop there. This understanding of the lung-brain dialogue could also change how we deal with infections where bacteria hide in biofilms. These sneaky bacteria often lead to asymptomatic periods, where the person appears to be healthy, only to have sudden illness flares. This is a significant issue in modern medicine. It's like playing a game of hide-and-seek with these bacteria, never knowing when they might jump out and say surprise. But with an understanding of this lung-brain communication, we might just have a better strategy to tackle these elusive bacteria. Remember, understanding this lung-brain dialogue could be a game-changer in dealing with infections where bacteria hide in biofilms, leading to asymptomatic periods and sudden illness flares. Hang tight because there's another intriguing piece of this puzzle, the role of gender in sickness response. Now, we all have heard of the term man flu, right? It's often used in jest to suggest that men, when they have a common cold, experience symptoms more intensely than women. Well, this groundbreaking research might just offer some scientific credence to this phenomenon. The study observed a significant difference in sickness behavior between males and females. It was noted that male mice showed a greater reliance on neuronal communications during illness. That's right. When the little guys were under the weather, their brain and lungs were chattering away more fervently than their female counterparts. This suggests that men could potentially have a heightened sensitivity to symptoms of sickness due to a more active lung-brain dialogue. Now, before you start jumping to conclusions, remember, this is early-stage research. While these findings are fascinating, more work is needed to fully understand the implications. However, it does start to shed some light on the biological differences in how men and women respond to sickness. This kind of research is crucial to improving our understanding of the complex interplay between our brains, our organs, and our overall health. It's not just about the man flu or gender differences, but about how our bodies communicate internally, especially during times of illness. So next time you or a guy you know is feeling under the weather, remember, it might not just be a case of the man flu. Your brain and lungs could be in a heated discussion. It's all part of the fascinating, complex, and sometimes puzzling world of neuroscience. So stay tuned for more exciting revelations from the world of science. With this newfound knowledge, what does the future hold for medical treatments? Picture a world where our understanding of the human body is so profound, we could treat infections and chronic conditions by targeting not just the pathogens, but the very neural pathways they exploit. As we delve further into the implications of this groundbreaking research, we begin to see a future where antibiotics are not the sole warriors in our fight against diseases. Imagine, if you will, a two-pronged approach that combines robust antibiotics with targeted treatments for the nervous system. Such an approach would aim to disrupt the communication between the lungs and brain, effectively cutting off the disease's control center. This revelation is not just about treating infections more effectively. It's about rewriting our understanding of disease management. It's about acknowledging the complex interplay between our organs and the brain. It's about recognizing that our bodies are not just a collection of separate systems, but a deeply interconnected network, where a change in one area can have profound effects elsewhere. In the future, we could see treatments that are tailor-made to harness this connection. For instance, in cases where bacteria hide in biofilms, leading to asymptomatic periods and sudden illness flares, we might employ a combination of antibiotics and neurocircuitry treatments to prevent these stealth attacks. And what about chronic lung conditions? Could we see a future where we not only treat the respiratory distress, but also the neurological pathways that exacerbate it? It's a tantalizing possibility that could revolutionize how we manage these conditions. But this is not just about the future. It's about the now. It's about the countless researchers and medical practitioners worldwide who are already using this knowledge to rethink their approach to treatment, to challenge the status quo, and to push the boundaries of what we thought possible. Indeed, the future of medicine might be more intertwined with our nervous system than we ever imagined. As we continue to unlock the mysteries of the human body, we find ourselves standing at the precipice of a new era in medical science, an era where our understanding of the body's interconnectedness could lead us to treatments that are more effective, more personalized, and more in tune with the complex symphony that is the human body. So there you have it, folks, the lungs and brain part of a secret club we never knew existed. Who would have thought these two, seemingly unrelated parts of our bodies were in constant communication, especially during infections? We've been through a journey of discovery. We've learned that the traditional view of sickness response has been flipped on its head. It's not just the immune system triggering those unpleasant symptoms. It's also the brain, receiving direct messages from the lungs through previously unknown neurological pathways. This revelation challenges what we thought we knew and invites us to rethink our approach to treating respiratory infections and chronic lung conditions. We've also delved into the gender factor, discovering that males might rely more on these neuronal communications during illness. This could potentially explain why men often seem to suffer more severe symptoms when ill, the so-called man flu. But what does all this mean for the future of medicine? Well, it opens up new avenues for treatment. It's not just about targeting the pathogen anymore. Now we also need to consider this newly discovered communication between the lungs and the brain. By understanding and addressing this lung-brain dialogue, we can develop more effective treatments for a variety of lung infections and chronic conditions. This groundbreaking discovery is just the tip of the iceberg. There's still so much to learn about the complex interplay between the brain and other organs in our bodies. But this is a significant step forward in our understanding of disease management. So next time you catch a cold, remember, it's not just your immune system at work. There's a whole conversation going on between your lungs and brain. And don't forget to subscribe to our channel for more fascinating insights into the world of science and health.